Do you feel the vibes?
It's a pleasure to welcome you all for the course 19EC 503 Microprocessor, Microcontroller and Interfacing. We'll be detailing on the topic Programmable Peripheral Interface 8255. Before getting into 8255, we just want to know what 8086 is all about, where it has been utilized. So 8086 is an 16-bit microprocessor that helps us in doing all basic arithmetic logical operations. But 8086 found to be inefficient in connecting external devices to it. So to provide an external interface, we want to have another interfacing connection. One such connection is 8255. So the main ideology of this video is to make you understand what is 8255 and how it can be interfaced with 8086. So first thing is 8255 is an I/O port chip used for interfacing I/O devices with microprocessor system. And then you'll have a device used to implement parallel data transfer between processor and slow peripheral devices. The examples of slow peripheral devices are analog to digital converters, digital to analog converters, keyboards, 7-segment display, liquid crystal display, and so on. So this is how these are the basics idea of 8255. 8255, it has certain features among it. First thing is it's a programmable device. 8255 is commonly called as programmable peripheral interface, or it can also be referred as parallel communication. Before detailing about the features of 8255, it is important to know that 8255 supports us for parallel communication. That is the reason why examples are quoted like ADC, DAC, 7-segment and all. Again, I repeat, it is based upon parallel communication. Coming back to the features, it is programmable, of course, and it is 24 I/O programmable pins. The 24 I/O programmable pins have been grouped into different sets of pins, and those are analyzed as port A, PA is port A, PB is port B, PC is port C, which is of 8 pins each. Like you'll have 8-bit of access through all these ports, and then it is TTL compatible. So these are the features of 8255. As I've already mentioned, the 8255 has 3 ports: port A, port B and port C. So port A and port B are 8-bit parallel ports, and port C can be divided into 2 major halves. It can be divided into port C lower, and it can also be divided into port C upper. So 2 different types of port C can be categorized. One is port C upper and another one is port C lower. The next ideology is we want to categorize, we want to group this 3 different ports into 2 groups. Port A and upper port C will be group A, and port B and lower port C will be referred as group B. This will be helping us. The main need of grouping these ports is for easier access. You can easily access or you can easily send or address data whenever it has been required. So that is the reason, and it will be reflected in the block diagram. I repeat, group A is port A and upper port C, and group B is port B and lower port C. So these groups can be programmed in 3 different modes. 2 groups with 3 different ports, and it can also be accessed in 3 different modes. The first mode is simple I/O port, which is mode 0, and the second one is handshake I/O, which is mode 1, and you'll have bidirectional I/O, which is mode 2. I just want to explain on each of all these modes. Mode 0 is nothing but a simple I/O port where you can connect a device, or you can feed an input through which you can analyze the output. So you're feeding the systems with an input, expecting for an output. That is mode 0. Mode 1 is handshaking mechanism, where you want to analyze, where everybody will be very aware of this ideology, where we want to provide an handshake. So the first, assume it will be a transmitter, and you can also be analyzing it as receiver. So one part is transmitter and the other part can also be will be a receiver, and also it can be a transceivers at the time. So the first thing is we'll send an RTS. RTS is nothing but request to send. Are you free? Shall I send the data? So request to send. If the receiver is found to be free, it will send clear. It will give a clear to send signal, followed which the data will be, followed which the data will be transmitted. After sending the data, the receiver will intimate the transmitter that everything that you have been transmitted has been received through an acknowledgement signal. So this mode of transmitting and reception can be done through mode 1, especially for important data. So that is handshake IO ports. And the last mode is bidirectional modes, where we can expect both the ends of the devices can either be transceivers or receivers. It will be providing a bidirectional data communication. So 3 different operating modes. And the best example is a computer being connected to one printer. If you're continuously giving a input to the printers won't accept it all the time. You have to check whether the printer is available to take a print. Yes, if the printer is available to take a print, we can give a PDF or a document that can be fed into the printers. Suppose if the printer is not accepting, the computer has to tell that there is a data available in the data bus, and then the printer has to be accepting it and printing it on the sheets that you've been feeding it into the system. So that is the best example of a parallel communication, and also a handshake mechanism, how it can be expanded. So each port uses 3 lines from port C as handshake signals. So this is a beautiful diagram that represents the pin details of 8255. So this is very simple. Like you'll have port A, and then this is also the group of followed of port A, and then you'll have port B being represented in the color of green. This is also yet another group, and you'll have port C pins being highlighted, and you'll have all these data pins through which you can come to a conclusion that it can access 8-bit of data. And then you want whatever the pin, whatever the IC you choose, it is important it should have a reset button, because then it has been dumped with unwanted data. It has to be resetted for operating on the current situations. So resetting, and you want to know what is read and write. So if you want to access a memory, you want to read it. You want to read what the data is available in the memory. If you want to overwrite the particular data in the memory, then you have to go with the right options. And what is the type of chip that you want to choose? That is chip select. And then when you have a supply, you want a ground. So these are the very basic and the simplest pin diagram that you can expect in your semester question papers. And through which what port I can select. Then another question is, we have 3 different ports. What should be the mode? What should be the input that I have to feed to 8255 to select the ports? So for that question, the answer is you want to choose 2 different address lines. One is A0 and another one is A1. For giving multiple options as input, you can choose different sets of ports that has been available. First thing is port A, second thing is port B, and port C, and the control registers. The options have been highlighted over here. So we just came to the last part of our presentation, which is the block diagram 8255. So here it is a very neat diagram again. Why? Because it has been highlighted in that way. So you have group A. We just want to target on the centermost part of this diagram. You'll have port A, it is group A, and here you'll have group B. So group A, when you just come closer and analyze, it has group A, that is port A, and you'll have port C upper. So from with this, you can conclude that port A and port C upper contributes for the group A, and port B lower and port B will be contributing for group B. So this is how it will be reacting, and you'll have input output ports for each individual ports. How it has been represented have been given as input lines. You'll have a common data buses for sharing the data, and you'll have a data bus over control, and then you'll have a read write logic control, and you'll have a supply and a ground button. You'll have all these chip select, reset, A1, A0 for selecting the ports, and read and write. So this is a beautiful block diagram which is very easy also to remember. Like when you should be very clear that how the ports have been grouped and what are the names of that particular group. So I just want to summarize what we have discussed so far. 8255 is a programmable peripheral interface, and it is used for parallel communication. It has 3 different types of ports. 3 different types of operating modes. Mode 0, Mode 1, and Mode 2. It starts with simple IO, handshaking, and bidirectional. Talking about ports, port A, port C upper are group A, and port C and port C upper and port B are group B. Control. So this question is the most important question you can expect in any of your semester's examinations. So I hope this video I've given you enough explanations of 8255. If there's I hope the information shared in this video are informative enough. Thank you so much.